So today we will try to understand Apache Spark. Apache Spark. So what is Apache Spark? So Apache Spark is a in-memory computation engine. So in the definition of Apache Spark, there is a keyword called in-memory computation engine. What is the meaning of in-memory and what is the meaning of computation? We will try to understand. So what is the definition of Apache Spark? Apache Spark is a in-memory computation engine. So in the Hadoop, if you see the Hadoop 1 provide us three things. Hadoop 1 provide three things. One is HDFS, second is computation, second is MapReduce, third is yarn. So HDFS means storage, MapReduce means computation, and yarn means resource manager. So Hadoop provides us three things: HDFS, MapReduce, yarn. In latest Hadoop architecture, we are replacing this MapReduce using Spark. That's why we called Spark as a computation engine. Instead of MapReduce, we are using Apache Spark or Pyspark, what you want to say. Why you are moving to Spark? Because Spark is 100x faster than MapReduce. Why Spark is faster and why Spark is in memory? We'll try to understand. See, if there is a HDFS in Hadoop, if there is a MapReduce 1 job, MR1, MR2, MR3, MR4. So if this 4 MapReduce job is there and it is running in a system, so it will do what will it will do? It will read data from HDFS. Okay, after some processing, it will write back data on the HDFS. It will read data from this is also MapReduce 2. This is MapReduce 2 job. It will read data from HDFS. After some processing, it will write back the data in the HDFS. Also same MapReduce 3 also read data from HDFS and write back to HDFS. MapReduce 4 job will read data from HDFS and write back to HDFS. So if you see this diagram, we can see for every MapReduce job we are performing two IO operation per MapReduce job. This is important. Be careful. For every MapReduce job, we are reading data from HDFS. Then after processing, we are write back that data in the on the HDFS. So we are performing two MapReduce job. There is a 4 MapReduce job in this diagram. So four MapReduce job we are performing 8 IO, 8 input IO, input output operation. Okay, so 2 input output tasks operation per MapReduce job. For 4 MapReduce job, we are performing total 8 input output tasks. That's how MapReduce work. And this is one of the reason the MapReduce is slow, because every input output operation take time, lot of time, and it makes MapReduce slow. But how this situation is handled in Apache Spark? Let's see. So in Apache Spark, there is a concept called RDD. We don't want to go that concept now because we don't know what is RDD. So take this as a variable. So let's take variable 1, variable 2, variable 3, variable 4. So there is a 4 variable. Okay, 1 variable 3, and here is a HDFS. So, and these in Spark, all of this variable will be in RAM. Okay, random access memory. All of this variable will be in RAM. That's why Spark is in memory, because all of this variable will be in RAM. So Spark will read data from HDFS. So it will read data from here, and it will do some processing in this variable. After that processing, the result will write back to in this variable 2, not here. So Spark will read data from HDFS after some processing in this variable 1. So Spark will read data from HDFS and write that data in the variable 1, and then processing that data in this variable, it will write back that data on this variable 2. So if I am reading x equal to 2, and I am adding x plus 2 here, so the result will be 4. So 4 will be write back in this variable 2. Then Spark will perform some operation on the top of this, on the top of the data. So my data is 4 now. So Spark will do some processing. So it will add some 3 value. So now the data is 7. So this data will write back on that variable 3. Now data is 3. Now Spark will do some operation on this data. So my data is 7. Value of the data is 7. So what it will do? It will again do some operation. So it will add some value 3. So now my data value is 4, and the data value will write back to in variable 4. So value is 10. So it will write back to variable 4. So 10 will come here. Now for our now Spark will do some other operation. So it will add 2. So it will be 12. So Spark completed all of this operation in this variable. End of all of the operation, it will write back the data on the HDFS. So if you observe, we are reading data from HDFS and writing the data in variable 2, variable 1. After doing some operation in this variable 1, we are writing that result, the data in variable on the variable 2. After doing some operation in this variable 2, we are writing the data on the variable 2, variable 3. And again, we are doing some operation here and writing back that data, means result, on variable 4. Then we are doing some operation here. Then we have completed all operation. Then at last we are writing back the data on the HDFS. So for whole thing we need only two input output activity, two input output operation, only two. And for uh, for uh, for our MapReduce, we need 8. There's a 4 MapReduce job. Total, we need 8 input-output tasks. Here, we have total 4 variable. We need only 2 input-output tasks. For MapReduce, we need 8 IO. For Spark, we need 2 IO. And every input-output takes time. That's why Spark is faster than MapReduce. One of the biggest reason is this. This Spark is take lot of less time in input output because we performing less input output activity, and that's why Spark is taking less time than MapReduce, because MapReduce is taking lot of MapReduce is performing lot of input output tasks. This is one of the reason. That's why Spark is faster than MapReduce. And all of this variable will be in RAM. We will do all of this computation in RAM. That's why it is a in-memory computation engine. We are not writing back data into disks, our hardware, our hard drive or our drive, then reading the data from the drive. Not like this. We are reading data from drive or C drive or E drive, then doing all of this operation in RAM. Then at last we are writing back to our C drive. Or like I am giving you example. For MapReduce, we are every time reading data from our C drive, then performing some option, then writing back to C drive, then again reading from C drive, then writing back to C drive. So it will take a lot of time. But here we are only once writing, only once reading, only once writing. Here we are reading, writing. So that's why it is taking time. MapReduce is taking time. And one of the biggest advantage of uh, Spark, it is give it can perform a lot of tasks. Okay, I will discuss later like more about this. So if you know peak, storm, MapReduce, these thing before Apache Spark we have to learn separately. Each of these component have separate importance before the MapReduce. Before the Apache Spark introduced, we have to learn this, we have to learn this, we have to learn this, because these things are for different things. This is the individual component. We have to learn this peak, we have to learn storm, we have to learn MapReduce to be good data engineer. But now this everything can be done by Apache Spark. It means what this peak, storm and MapReduce can do, only Apache Spark can do those things. Only Apache Spark can cover all of those things. Before that, peak is individual thing. We have to learn peak. Before that, we have to learn storm. Before that, MapReduce. But now, if we learn only Apache Spark, then there's no problem. We can do everything what we are doing here, and it is more efficient. So that's why Apache Spark is popular. Apache Spark, like Pyspark, same. Apache Spark or Pyspark, same. When I am saying Apache Spark, it means Pyspark. So in this lecture, that's it. I will not cover more. This is my first lecture. So handwriting is bad, I know, because I am writing in tab, and that's like I cannot do it. I cannot give you a good handwriting here, but I am trying to explain you why Apache Spark is in memory, why Apache Spark is faster. Because if you like, if you interviewer asks, tell me the definition of Apache Spark. So you will say Apache Spark is in-memory computation because you read that from a website. But when interviewer asks you why, what the meaning of in-memory, what is the meaning of computer engine? What is the meaning of why the Spark is faster? We have to explain like this. So this is the lecture 1. Okay, lecture 1 on the Apache Spark, and this is the basic lecture. And in this lecture, that's it. I'll cover only this much. Next lecture we will see about RDD action and transformation, those things. So for this lecture, that's it. We will see in the next lecture. We will cover in next lecture. I will try to cover RDD action transformation. We will go step by step. Okay. First lecture we will try to understand what is the Apache Spark, what is the why Apache Spark is faster, why is so popular, what is the in-memory means in the definition. So I hope you like this lecture. See you in the next video.